Hello everyone, my name is Keshvi Santokhi and today I am going to talk about channel capacity for noisy channel. So let's begin. Channel capacity is the maximum data rate at which data can be transmitted reliably. In real life, every channel has noise and because of that we cannot transmit unlimited data. In Forozon also, it explains this by using Nyquist bitrate and Shannon capacity. But for noisy channel, we mainly use Shannon capacity. For example, just like a road has a speed limit, a communication channel also has the data limit. Understanding noisy channel. A noisy channel is one where unwanted signals called noise disturbed by the actual signal. It means that the noise disturbs the actual signal. Noise may come from the environment, electronic device, or heat. Because of noise, the received signal is not exactly the same as the transmitted one. Let's take one real world example that while we are talking on the phone near the traffic, background sound interfaces with our voice. So it is also type of noise disturbance. Key models for the channel capacity. There are two main models, that is Nyquist bitrate, that is for ideal noiseless channels, and Shannon capacity, which is for noisy channels. Since real channels always have noise, Shannon capacity is more practical. Nyquist is like an ideal classroom silence, and Shannon is like a normal noisy classroom. The Shannon capacity formula. This formula is C is equal to the log base 2 plus 1 plus SR, where C is the channel capacity, B is the bandwidth, and SNR is the signal to noise ratio. This formula gives the maximum possible data rate for noisy channel. Think of bandwidth as a pipe with and the SNR is the water cleanliness. Interruption of the Shannon formula. This formula tells us three important things. First, it gives the absolute maximum limit. Second, increasing signal power cannot give unlimited data rate. And third, capacity increases if bandwidth or SNR increases. For example, even if you speak louder in a very noisy place, communication is still limited. Means it doesn't affect whether you speak loudly or slowly. Signal to noise ratio, which is SNR. SNR measures how strong the signal is compared to the noise. Higher SNR means clear signal and higher capacity, and lower SNR means more errors and lower capacity. Let's take one real world example for this also, like teacher speaking loudly versus a student talking in the class. Like single person is talking loudly but there are many students, so the more powerful will be the students only. Key principles from the Shannon formula, we can take some key points like more noise, which has less capacity, more bandwidth is equals to more capacity, and there is an absolute limit for this. The Shannon formula provides an absolute theoretical limit that No practical communication system can ever achieve a data rate beyond the calculated capacity. A narrow road which carries fewer vehicles than an highway. Prac- Practical applications where bandwidth is of 3000 Hz and SNR is 1000. Using the Shannon formula, the capacity will be equivalent to 30 kbps. This means this capacity cannot be reliably transmitted more than 30 kbps. Why channel capacity matters? Channel capacity is important because it requires design communication system. It requires it helps to decide required bandwidth. It helps to predict the performance. So that's why channel capacity matters. For example, before building a bridge, engineer calculate how much load it can carry. So in conclusion, I want to say that channel capacity defines the maximum reliable data rate. Shannon capacity gives the true limit for the noisy channel. Thank you.